Hi, I'm Andy Lazur. I'm a water quality specialist with the University of Maryland Extension, and I'd like to talk to you about drinking water quality testing. So, several discussion topics are, do I really need to test my water? Can I test it at home? What should I test for? And what do those results really mean to me? So it's important to know that in virtually all our day-to-day activities, whether it be recreation, transportation, home activities, cleaning, washing, showering, makeup, whether it's farming, industry, there are numerous potential sources of contamination that get into our waters, our surface waters, rivers, streams, lakes, etc. And then also get into the soils and then slowly infiltrate down into our groundwater. And then our groundwater can then be pumped up through a well and supply our homes with drinking water. So looking at the need to test my water, it's really important to think about your body is made up of 60% water. And it's a vital nutrient for your body to function properly. So it just makes sense that you want to put in good water quality to provide optimum health. So when you think about testing my water, consider the source. You know, are you on a public supply or are you on a private well? Now with public water, it's regulated by the EPA and states, and it's tested for currently 97 contaminants, and that's regulated by the Safe Water Drinking Act. And those 97 contaminants are made up of various minerals, various types of organic contamination, radionuclides, such as radium, and even, of course, bacteria. It's also important to know that as a public supply consumer, EPA mandates that water utilities provide customers an annual, what's called Consumer Confidence Report, which is basically a summary of the water quality. Now, private wells, on the other hand, are not regulated. So it's the responsibility of the homeowner to test and ensure both the safety and the quality of that drinking water. EPA has developed limits for public water supplies and standards. And these standards are either primary standards, those are pollutants that cause human health issues, and they use the term maximum contaminant level, or MCL. And then the other standards are secondary standards, which are aesthetic pollutants, things that affect the taste, the odor, or cause stains. Here's an example of a consumer confidence report. And as you can see, it's a wealth of information. It points out the different contaminants here, and it tells you what is the EPA limit, and then it'll actually show the results. And in this case, it's showing that there's no violation for this particular report. Here are the metals and minerals. Here are the radionuclides. And here's another continuation of that example where there's other contaminants, some organics, turbidity, coliforms, and actually chlorine. Chlorine is used as a bacteria disinfectant essentially, and so they show you that if there's any residual of chlorine, excessive residual of chlorine. So again, a wealth of information that you have access to, and if you haven't seen one before, then call your utility and be sure that you get your annual report. Now, we've probably all heard about lead issues, lead toxicity. Example most recently is the Flint, Michigan crisis, where there was toxicity due to changes in the treatment. And it's important to note that lead is not coming from the water supply, but it's actually coming from the plumbing that's used, the infrastructure, the plumbing infrastructure. And so many years ago, lead pipe was often used as a means of supplying water. And then also there's various types of fittings, copper fittings, where there was lead solder that basically would form the connection around the copper fittings to the copper pipe. And then there's brass fixtures, and the term lead-free, essentially. So over the years, they've tried to reduce the amount of lead in fixtures and fittings. Steel, galvanized steel, contains a little bit of lead. And again, since 2014, the amount of lead level has essentially been dropped significantly, or in many cases is zero. But it's important to note that lead itself in a fitting does not necessarily mean that you will have lead in your water. It takes corrosive water, whether it be low pH water, and then there's other chemical involved that can create corrosive water. And so it's corrosive water plus the lead in the plumbing that can lead to lead in the water. So this diagram shows that public utilities are responsible for all the plumbing infrastructure up essentially to the house, past the sidewalk. And then the homeowner is responsible to maintain this service line, and then obviously anything inside the house. So if this is lead pipe here, or you have some older fixtures that might have some copper solder, lead solder in there, that could be a risk, particularly if you have corrosive water. If the water is not corrosive and the treatment plants treat for that to reduce any potential for corrosion, then you would be, again, covered there. But again, you don't know unless you have that water tested. And sometimes homeowners will test for lead just to be sure that they're not having any issues with lead in their drinking water. EPA is a wealth of information on drinking water quality. Here's just an example of a brochure about lead. Talks about what the risks are of lead, and then where to get information as far as minimizing that risk, treatment, potential, those things. Great, again, a great resource. Now, well water, again, as mentioned earlier, it's up to the well owner to test for water, and these are our recommendations. We recommend annually to test for coliform bacteria, E. coli, and nitrates. These contaminants are indicators of animal or human waste. And in the case of nitrates, could be an indication of fertilizer contamination. And we recommend annually because groundwater does move. And in a case you may have not had any issues with these contaminants over the years, but it could be that there's activities going on. Maybe it's a failing septic system or livestock operation that has over time introduced bacteria and nitrate into the groundwater, and then it has reached your well and now is pumped up. So again, that's why we recommend that you test annually. And then for every 3 to 5 years to test for these particular contaminants here. These are important contaminants to understand. The chloride and the sulfate and the pH could influence the corrosion capacity of water. And then there's this other contaminants of local concern that you can find out from your health department, that you may be in an area that has a natural contaminant, say of arsenic or radium, and that's due to the geology. It's important to note that a lot of our water quality is based on the geology, where that water comes in contact with the rock and the soils, etc., picks up nutrients and potentially contaminants. So your local health department will know if your well is located in a deposit, geological deposit that may have some of these contaminants. The other thing that might drive you for testing is you may be seeing some things or tasting some things that you're concerned about. And so here are some examples. So if you're having stains, orange or black stains, that could be either iron or manganese. If it takes, a lot of soap in order to get lather, that may be a hardness situation. Obviously, salty taste could be coming from chloride or total dissolved solids. You could have a chemically smell or taste, and there could be some contamination there. The other thing is that you might have some blue stains on your fixtures, for example, or pinhole leaks. And that would be an indication of perhaps low pH or corrosive water. And so it's important to know these things, and this is what you want to test for. So we have a couple options on how to get our water tested. We first recommend that you contact your state or your county health department, because they may actually offer free or reduced cost testing. And again, they can provide that information on local contaminants and also give you information about private water testing labs. So again, a great resource there. The other option is to use a certified drinking water testing lab. And these labs are a great resource. They have been certified. The analysis methods that they use are approved by the state and are very accurate results. And so it's a resource. It's also important to know that the labs will provide you with everything that you need: how to take the sample bottles themselves, and then shipping instructions. Because for some contaminants, you actually have to put the sample on ice or a gel pack and then ship it within a certain period of time so that the test will be accurate. So a great resource there. A third option is to use a home test kit. And these can be good for preliminary results. They don't have the accuracy as a certified lab, but they can provide an indication of whether there's a presence of a contaminant of concern. And if you do get a positive result for a contaminant and the test kit suggests that it could be a concern, you definitely want to follow up with a certified lab to get a more accurate and more detailed information on that, so that you know what to do with that, say for some treatment, for example. So here's a great online tool that you can actually take the results that you get and plug it in to this tool. This is put out by Penn State Extension. And it will tell you, give you a wealth of information, what those results mean to you, and then provide even some possible treatment options. So this slide here, I've plugged in a couple of contaminants, zero bacteria, a little arsenic in there, copper. Here I put in, knowingly put in a nitrate level that exceeds the EPA recommendations, and put a low pH value, just to give you an indication of what this tool can do. So in the case of these here, and arsenic and copper and lead, these were all within the standards. In the case of nitrate, it basically said that if we exceeded the 10 milligrams per liter or parts per million. And then we can click on here and it'll give us more information specifically about nitrates, including what we can do to treat that water. And then the pH here is not a human health risk directly, but a low pH could be an indication of corrosive water which may, as we talked about earlier, may be a source of various metals if you have older types of plumbing. So again, a great resource for you to take advantage of. The other important thing about contaminants is that there are a wide variety of treatment options out there. And so this chart just shows you the different types of treatment systems that can be used for specific contaminants. So for example, if you have a hard water situation here, again, remember it might take or might be very difficult to get soap to lather up. There's options here that you could use a ion exchange, a water softener. If you have radon, you could use a activated charcoal filter here. So again, for virtually all the contaminants out there that we test for, there's a treatment system out there. And it's important to know that you have options too, not only in the types of different types of filtration units, but actually how they're put into your home. So here's examples of what's called point of use filters. For example, putting a device directly on your kitchen faucet. Here's a refrigerator-based water filter. And then there's under the sink options as well. Now again, these are filters that you put on to provide drinking and cooking water directly at the source, or the point of use. The other option is to have what's called point of entry or whole house water filters. So for example, if you had hard water and it was creating issues with scaling, then you could use a whole house or point of entry water softener, for example. Just be sure when you were to buy a treatment device, be sure that it meets the standards and look for that NSF label. It's very important that it's been verified to remove the contaminants as is on the label. So concluding, there's a wealth of information out there. EPA has a tremendous amount of information on various aspects of drinking water. I encourage you to look at these resources and rely on them to be better informed, to know what you're drinking. And again, that's great for peace of mind, but also very important for your overall health. Thank you.